Hello, I'm Scott Clifford with Clifford Manufacturing. In this video, I'm going to show you how simple it is for even an idiot like me to drive and control a stepper or servo motor. And we're going to do this with a $10 programming board made by Cypress and Infineon. And we're going to do it with only 6 lines of code, which is pretty cool. So we can drive these guys, 23s, little bitty guys like these, or even these bigger guys from Techniques. It doesn't matter. We'll even be able to drive multiple of them with synchronous movements with a little $10 prototyping board. So let's get to it. Before I get started, I thought I'd tell you where we're going with this because I've had a lot of questions about how I control my fully automatic servo injection molding machine. And so this is the start of the videos of teaching how I did that. My first controller was this controller here that I use, and again it uses the same Cypress slash Infineon. It's called a CY8C Kit 059, and that's what I just love this little board for 10 bucks. It's got tons of power, and that's what I attached to my little controller to control it. But it had a lot of deficiencies. One is I needed to control the thermocouples, which was 3 of them, and I wanted a better display and interface. So coming up, and you'll see, and I offered on my website, I developed this board here. And this board has all the I/O available out of that 059 board, and you can put pins in it, and on the back you just literally plug it in like this. You plug it into the unit. Let me do it here so that you see. So you plug it in just like an AC. So if you ever break one or whatever, you can just replace it really simply. And then you have access to all those I/Os. Plus, it has a 3 amp 5 volt power supply that works up to input voltage of over 80 volts. So you can power it from, the larger power supplies like the ones for Techniques, which I like to use. So it makes it really simple. No other things you need to connect. And then what's really cool is you can actually interface one of these touch displays here. So this is touch display. It's made by New Haven, and it's an Eve display, so it doesn't take up processor power. So it's really nice. And you just literally plug it in, and now you have a full touch display to make a complete controller of. And again, this is a device that I offer on a website. You can see it's called Kyle 059 is what this product is called. You can buy it with or without the display. So I'm going to now continue on and show you how to actually write some code and control motors with only 6 lines of code. So here we go. Okay, before I get started, I thought I would explain to you why I like the Cypress and Infineon. It's actually their partner is called CY8 Kit 059. And what's really cool about this part is it comes with a 32-bit processor, ARM core processor. It's loaded with memory, can run up to 80 megahertz. And what really sets Cypress apart from others is they have these 2 features here that we're going to take advantage of to do this, to allow me to actually control a stepper or servo motor with just a simple command set. And so it has a programmable analog and also programmable digital. And in fact, we're going to use some of the UDBs in there, and as well as some of the programmable analog to do this. Also, it has really nice, it has a 20-bit ADD converter in there, which is really suited for, because they have other processors too that are actually a little cheaper, like their PSOC 4 series. But this part is really good for analog and digital. But it allows me to control my thermocouples, so I can actually read the very low currents and voltages on a thermocouple. And that's one of the reasons why I selected this one. They have other ones, like they have an 043, which I use to control motors with, which is a really cool unit also. But that's why I did it, and it's also loaded with plenty of other stuff. It really is a really cool part. The other nice feature is it has a world-class IDE, which is their integrated development system. And I really like, it's called Creator, Cypress Creator, or PSOC Creator actually. And I really like it because it sort of works the way an engineer thinks, and you'll be exposed to it as I go along here. But it really is a world-class unit, and I think a lot of people have copied it over years. I personally think Cypress microcontrollers are one of the best kept secrets in the industry. They're quite well known, and guys doing true embedded work where they're actually doing real product development. As a matter of fact, I've developed several products using Cypress microcontrollers, so they're really cool. I mean, you can get some parts like a 32-bit processor with, I don't know, like 24 pins. You can get it like for 50 cents. And so if you really need to, make a product that's inexpensive and that's something you can really make some money on, you should consider them because they're really top-notch. And with Infineon, which is, I just love it, they have some really great motor control stuff and plenty of other stuff, including really nice FETs, Hall sensors. It's just unbelievable. So between adding those two together, I think is just a potent combination. So anyway, you'll get to see some of that in this video, how powerful this stuff is. Another thing they do is it has this particular kit, it exposes all the IOs. So you have up to 48 IOs that you can get to on this little board. Really nice is it has it's a breakaway, where actually right in here you can break away the header, and this is a programmer. And so it comes with a built-on programmer that you can leave on or off. I leave it on my units, but you can actually take it off and still have access to program it here through these pins right here. So that's really cool. And then you can also program it and debug through this is a little plug-in. You can literally plug this thing into your USB port on your PC with no cables and actually make this thing play. As a matter of fact, I'm actually just have an extension cable from my PC to this in this video, so that's all I'm using to control these servos, including steppers. Let's see what else I got. It also has a little built-on switch, which we'll use in our demo right here to actually make the motor go, so that's really cool. And then it also has an external USB, because this particular, the PSOC 5 has USB stuff built straight into it, so we won't be using that, but that's really cool. And then the last thing, it has a little onboard blue LED, which we'll also utilize. Just helps to indicate stuff, and very helpful actually. And then the last thing is the reason why is it only costs $10. So I mean, how can you beat that? You get all of that for $10. Programmer, everything. Now their IDE, none of that stuff. It's all free. Their compiler, a C code compiler, which is one of the industry's best, is all free. So nothing costs you any money. So for $10, you can do this. Now, the next thing, as I showed you earlier, is I take my board and I actually put some pins on it. And what I thought I would do is, before I do that, I wanted to show you in my video here is I take these extended headers for my my board. So I take these on my board and I solder in these extended headers like this, as you can see in my board here. So you can plug it in if you're going to use it. I really don't use these prototyping boards, honestly, very much at all. I really typically go straight to a board. But if you're going to use these, that's the best way to do it, is to buy these. You can get them from like DigiKey or Mauser, these little extended headers, and plug that in to your 059 board. It allows you to get to it. Matter of fact, if we go to my controller here, I'll pull it up. Okay, so on mine I just put the straight pin headers in, and that way it's low profile on the back of the board. And then literally I take the board here and I plug it in so I can get it in and out or do repairs or whatever I need to do. So anyway, that's the way I do it. Just some suggestions how you can configure your own little prototyping board. I buy mine directly from Cypress. I seem to get them pretty quick. These days, pretty much any CPU's on allocation, it seems. But I don't know, I got mine, they were on stock, but I only took a couple days and I ordered 5 of them. So anyway, I encourage you to order them. You can order them direct from Cypress, or you can order them from DigiKey or Mouser, your favorite electronics place. Is how to do it. And again, for $10, you just can't beat it. Okay, so here we go. So anyway, that's my board. I wanted to show you that what's on that board. So anyway, it has, see if I can move my picture out of the way so you can see everything. So it has all the I/O. So here's on mine I labeled the motors, injection, toggle, and screw. But you know, in this board you could control probably up to 6 motors if you wanted. It's just a lot of the other I/O for like sensor controls. I developed this board actually so they could actually use Gerbil and actually control a 3-axis CNC, including all the limit switches and all the feedback stuff. You can even control a motor speed. So that's what this board is actually able to do. And then it also has here, of course, the display and also the audio. It has audio on it, so you can produce audio if you want. And then up here is the 3-amp power supply. So it's capable of inputting up to 80 volts and producing, I believe, I can't remember exactly, but I don't know, 3 amps at 5 volts at 3 amps. So you have plenty of power to do whatever you want with it. And then the real cool thing has these built-in thermocouple interfaces, including the references. So you can measure 3 thermocouples. In this case, on the injection molder, I need a forward, center, and rear thermocouples to do proper profiling of the material when molding. So anyway, that's up on the board, and again, I do sell the board. It's very reasonable, and you can buy it with or without a display. You can put your own Eve display on it if you want. This is an older one, an Eve 2. You can put the newer ones on it too. The newer ones don't require this level shifter here if you want. But anyway, that's what's there. Now, the next thing I wanted to show you was the setup. Let me see if I can get my picture. I don't know where I'll put it right here. Here's a setup that I'm going to show you in the video. I'm going to show you how to drive just a regular regular stepper motor. In my case, it's a NEMA 23 little guy. And then also over here, we're going to show you how to run a Techniques. Now, the thing you need to understand for driving stepper motors is either they come with a built-in driver like Techniques, or the other ones require an external driver like the one here. This is a DM5 or DM542, very common. I can drive NEMA 23s with no problem with these. I think 34s even. But it's very common, and especially the connections are quite common. And so they're either connected common anode or common cathode. And this picture shows common anode, meaning that the anode of the little embedded LEDs in the optical couplers are pulled to 5 volts. So the anodes are commonly connected to 5 volts. You can also control them the other way, and I put that in here also. Let's see if that works. Let's see. Here it is. And that's common cathode. But again, in this particular video and the actual connections that are on you're going to see are connected common anode for the stepper motor. And then there's common cathode. And then for the Technique, here's the Technique onto the right side. And for the demo I'm going to show you here, it's connected common cathode. So in other words, all the grounds are connected commonly. But you can also connect it the other way also, which is common anode. And it says common cathode, but that's an error. Actually, I should fix that. But anyway, that's the connections. And that's what I'll show you. So I wanted to show you how they're all connected up so that you could do that yourselves. And that is exactly what you're going to see. So now I'll show you how to set up the PSOC 5 kit and write some code to do that. Okay, this is, I have a PSOC creator. This is their embedded development system, or IDE they call it. This is what it looks like when you open it up. And again, you can download it for free off of their website. Matter of fact, when you buy the kit, there's a link to it. It'll give you all this stuff with just one download, and you get everything, including a little demonstration on the kit and everything. So it's very simple to download. I thought I'd give you a little review of it first before I get started. Again, your projects are over here, and I have 3 of them in here. The first one is what I call a bare bones stepper, all right? And this is the project we're going to work on first. So you basically open a blank project, you go File, and you open, and then you create a workspace, and you give it a name and load it up. You can either bring in a blank, I call these schematics, because that's what I love the way it works, because it works like an engineer thinks. I'm a double E, so I like to think in a circuit-wise. I'm not the greatest code writer in the world, that's for sure, but at least it really helps me to think. But it comes up like this, and then what you have is here's the actual IC on the board, and here's the pinouts. And literally you can adjust the pinouts to wherever you want them pretty much. And then Cypress was one of the first to do this, so it allows you to actually connect the pin where you need it to do what you want with inside the chip. For example, here these happens to be the outputs here. There's the blue LED and a switch, and so here is the actual design we're going to work on. And the outputs are right here. So that's the pins that actually do the controls, control step, direction, enable. And here we go. So I thought what I do is just show you, I'll add a new schematic page. And this is what it comes in like. And what's really cool is Cypress has the ability to add components. They call them components, literally just like he was working on a circuit. And so, for example, to drive a stepper, you need to keep control of counts and the speed of the counts. So you need to control speed, and you need to control the number of counts. Well, a real easy way to do that, to control the speed, is with a PWM. So you could type in here PWM, and lo and behold, they have some PWMs that are available. Move my pictures. Let's see, they're over there. Oops. So here's the components, and there's a PWM. And literally you just drag them in. So there's a PWM, and I can use it. And then what's really cool is, let me zoom in on that. You can rename them, and there's plenty of videos online to show you how to do that. Matter of fact, there's a guy named Mr. I think it's Hawes. I can't remember his first name. But anyway, it's called PSOC 101. I encourage you to watch those videos. But basically, you set the parameters here to set up your PWM to control your speed. And in this video, I'm not going to go into the exact detail of that, because I'm going to pretty much do it for you to make it really simple, so you can just use mine and get to it. But in reality, you should really study these and learn how to use them. And what's really cool is they have a data sheet that's built into it, and so you can download the data sheet. Here it is, and it tells you everything about the part and how to use it, which is really cool. I actually print mine. I'm old. I like to print mine. And so that's a PWM, and that's how we would control the speed of our little steps. And then the other thing is we need a counter. So let's put a count, C-O-U-N, counter. Let's see if we can get, oops. Let's see if we can get a counter. And there's a counter, timer or a counter, right? So there's a counter. So that's really cool. So in code, you can actually control these and tell them what to do, and you can use the counter to count count the steps. And it takes a lot of code. You can Big Bang all this, but it's a nightmare. So you have to keep track of your PWM, and in a true action like a CNC and others, you really have to have this to be very flexible and be really easy to change. And that counter counts how many steps, so that on like a CNC, in this case, my injection mold, I need to control like the toggle, so I need to control its distance that it moves, as well as the screw moves, both linearly as well as in circles. So you have to be able to control counts to control the distance of your stepper or servos very accurately. Well, that's all well and good, but you have to do that all in code would require like interrupts and all kinds of things, and that just becomes real hassle. So it'd be really nice if you had the ability to do all this off chip. So if you could just say, okay, stepper motor, I need you to go this fast and go this far and be done with it, would be really cool. Well, that sounds really nice, but can it be done? Well, in reality, yes, it can be done, and I proved it, and I'll show you how that's to be done. So we'll go back to the actual project here. So here's the actual project, and you notice I have a counter, I have the PWM, and I have some of these, what they're called control registers, and that these are basically software controlled hardware. So this allows you in software to control hardware. Now, in real time, for this to work right, these all have to be synced up, and that was half the battle, was getting these things synced up properly. And it does require, you really don't need an interrupt, but you do need an interrupt to tell you when the movement is complete. So if you're doing, like, for example, a synchronous movement, like, I don't know, say filling the barrel with material and then moving the screw forward at the same time, well, those are synchronized movements. They need to go together at the same time. Well, you don't really want how to do that unless you know when your movements are complete. And so you need the actual, I'll call this the little external control to indicate when the movement has been completed. And that's what this little line does here. This is this little line right here. That an interrupt to notify me when the movement is complete. Now, we're not going to actually use it because it's technically not needed. If you want to actually control a servo or stepper very accurately, you don't need an interrupt. You can just tell it to do its thing. But if you do need to know when the movement is complete, you need that little feedback in it, and we'll use that on my second series of examples I'll show you. So basically, this literally is able to control the entire server or stepper literally outside the chip or outside the processor, technically, using the programmable component feature of a PSOC, which is really, really cool and simple. And these other devices right here, flip-flop and all these to sync this up, and this actually took me a lot of work, actually a long time to figure this out. And these other devices are your controls. Like this literally starts the action. So when I tell this baby to go, and I load these with my speed and my counts, it literally does it with one instruction. And this one controls the direction, and this controls enable. And that's as simple as it is. And these are the actual pins that are on the chip. And in this case, I'm using port 1, which you'll see in the demonstration. So that is it. Now, I know that if you're new to a PSOC, this might seem a little complicated, but honestly, it's really not. I mean, honestly, I don't consider myself that sharp of a guy, and I was able to do this myself. And a lot of this I even got started on the Cypress community. They helped me even get started. It didn't work at the start, so it took me a while to develop all the errors and get the errors out of it, but this actually works, and it works perfectly, and it's dead accurate. And so that's how it works. And so I was going to show you how it's all done, and then I'm going to show you how I can do it with 5 lines of code. So now we'll go to the code. So this is literally hardware that I've configured, programmable hardware, both analog and digital, and here's the code. So we'll go to the code, and this basically is going to move the motor in one direction, 360 degrees, and we can change it. Basically up here I've created four variables. Pardon me, four variables: direction, enable, speed, and step. So in this case, let me change this to 6,400. All right. So what that means is, let's change this to 5,000, and I'll show you what these mean. I developed a little spreadsheet, so it takes the mystery out of this. Up here, just to go through this code a little bit, I'll go from the very beginning. So that's all the code to move a stepper motor. Basically, I'm going to turn it in one direction, and I'm going to control the speed, and make it go exactly 360 degrees. All right. So the first thing in my code is I define a few things just to make my code readable and for me to understand. So I define the word forward, and I define it as a 1. In other words, it's going to be a 1. If I ever type in that word forward, it's going to be really a 1. Or reverse is going to be a 0, enable is going to be a 1, a disable 0, go is a 1, on is a 1, off is a 1. And that's literally just means when I type that in, it really means 0. Or I type that in, it really means 1. And so, for example, here I defined a variable direction, and I defined it to start off to be forward. And I've defined the enable to be enabled, so it's on. And the speeds to be 5,000, and I'll show you what 5,000 actually represents. And the steps is 6,400. Now I set up the driver, which I'll show you, which I set it up for, basically it takes 6,400 steps to make one revolution. All right, so, and that's as simple as it is. And then here I've done some little homework. So here I have to, here it says X speed start. So what that is that starts this component. In other words, I'm telling it in the Cypress processor to enable this component, and also the next line enables that component. So that's what these lines do. It enables those components. And then the next line of code, I enable the motor, so it's ready to go. And this is critical to understand. On a stepper, you need to understand when you enable that, that's when the motor actually starts getting hot, because it basically engages the motor. On a servo like Techniques, which is really cool, is once you enable it, it does enable it, but it does not get hot. And that's what's really neat about those drives, is they just not get hot. They're dead efficient. A stepper, you got to worry about this. But so, or at least you got to take into account or make sure whatever environment you're in, you're not going to get too hot when your motor's enabled. Then the next line of code, which I didn't include in my count because it really doesn't need it, is I read the switch, and basically when I get to the switch, I read it, and in this case it's pulled up, so it's seeing it high, and so it literally goes in there. It does nothing until I push the switch lower to when I push the switch. So once I push the switch, it starts writing or running this code. And then the next line of code, just for cool, I turned on the blue LED. And then the next line of code, I tell it what direction I want that motor to go. The next line of code, I delay. Now, this is a built-in Cypress delay, but if you need to read your manual on your driver, whichever driver you have, including Techniques or any others, is there's typically a limitation of after you write a direction, there needs to be a delay period after the direction, so that the unit knows what to do properly. And if you don't account for that, you'll get errors. On Techniques, it's really slow. I forget what it is. It's like not very long at all. But on this DM 54 or 542, it's actually 5 microseconds. I know that's not long, but anyway, it needs to be accounted for. And then the next thing I do is I write the speed. And then for the PWM, it's a 50% duty cycle, so I divide it by, so I have to write 2 registers in the PWM to get it to run properly. So basically it's on 50% of the time, off 50% of the time, and that's what this does. So that's all I need to set my speed. And then I write in the pulses. So here's where I write in the 66,400 pulses. And then I set go. All right. Now, as soon as this line is executed, the motor runs, and it runs without anything on the processor running. So literally it runs, and this thing is still running, so it doesn't tie up your code. So it's really, really cool. So I'll show you how it works. I thought I'd show you before I do that. Typically you build your project, and so you can build it here and make sure there's no errors. And there's no errors, but I thought I would show you anyway. Oh, I do have some errors. What did I do wrong here? Let's see, did I build all of the projects or build stepper bare bones? Let's see here. Let's see what I got going here. Terminal clock. Oh, that's the reason is because the errors are my little extra sheet I did, page 2. I need to get rid of these. Sorry about that. So let's delete that page. Alright, now we're back to where we should be. So I'll put this back down. And just to show you, I'll leave that open so you see it when you build it. You don't want any errors when you build something. And again, the programmer is built onto this little board, so it's really cool. You don't have to spend extra money, because sometimes the external programmers are quite expensive, $100 or more. So this one you get it within the $10, so you can't beat it. Alright, so it's fully built, no errors, and then I click this little key to program it, and we program it, and here we go. Alright, now let's just review our code. So in the code I've told it to go a speed of 5,000 and a single turn. So let's see if it does it. We reset it just so it's reset, and it should go 1 turn. Exactly, there it is. I'll hit it again. Exactly 1 turn. Now just to show you all, in my code I'll actually reverse it. So where it said direction, I'll change it to reverse. So in my code I'll change the direction to reverse, and then I'll reprogram it. So I'll hit it again. So it goes in the direction exactly that. Now in the code I'll change the speed. I'll double the speed. Alright, so it's now 2,500. I'll reprogram it, and it's reprogrammed. See, now it goes faster. Now I'll do it, I'll reverse the direction and have it go twice as many. So it's 12,800 steps. And then let's make it go the other direction, forward. Alright, then we'll reprogram it. So it's 2 turns exactly. So that's how simple it is. So that's how it's literally done with 6 lines of code. Matter of fact, one of the lines you technically could delete. So really, you don't really need that one. It is sort of needed, so really you could do it with really 5. But I think that's just amazing. That's the power of a PSOC. You can really do some cool stuff with these things. Alright, there we go. So the next one I'll do is I'll add a little complexity to it, is we'll add an interrupt now to notify you when a movement is complete. And in this setup I'll actually drive a techniques motor just so you see how that works. So we'll do that one next. Okay, in this section of the video I'm going to show you how to operate a techniques motor, and then we're going to also add in a feedback element, which would be the motion completion. So we're going to have an interrupt generated, and we're going to deal with that interrupt when the motion is completed. Another thing I wanted to show you on PSOC Creator here is I noticed these inverters and this flip-flop. I just wanted to make note of where you get those. You can just type in flip-flop, and there it is, and so you can load those in. Or if you wanted a inverter, you could just type in inverter and you got yourself an inverter. And then by connecting these up, I just wanted to show you how you actually do that. So if you wanted to connect these two up for whatever reason, you just go over here to your connection point, and then you just make a connection from there to there, and then grab it again, or you can double click on it and it will stay there. And that's how you connect all these guys up to do this kind of thing. So I wanted to show you that just in case you didn't quite understand where those came from or how I did All right. So anyway, this is our interrupt for end of motion. Basically, when this when this times out or the counter completes, it basically causes an interrupt, and that's what our motion is. Now again, this is the Techniques setup. Remember, Techniques has a fourth wire that allows it to do different things, like you can read torque, or if you can even have it indicate end of motion. We will not be using that, but I just wanted to show you it is in here in case you want to utilize it. And again, this is identical from the servo motor, or excuse me, from the stepper motor. The only difference is I changed the outputs here to a strong output instead of open collector, because it's a common cathode connection. Other than that, it's all the same. Let me go over the code with you just a little bit, and for the sake of time, I wouldn't. I'm just going to go through several motions at the same time to show you how easy it is to change different motions and directions, as well as this whole routine doesn't flow unless the end of motion is completed. So let me go through this code here real quick with you. As you can see, I broke our first initial 5 lines of code here. Let me move my mug out of the way here. Here's our original 6 lines of code, and I brought those into a subroutine so we can utilize it easier. But they're the same lines of code exactly. The only difference is we've added an interrupt here at the top of our code that needs to be serviced. So when the end of count occurs, it generates an interrupt, and this services it, and I set a flag basically. And then in the code, so let me show you where that is real quick. So there's our this actually runs the motor. So when that says go right there, the motor actually runs, and then it returns out of this code and goes back to our main code here, and it goes to this little guy here, and it checks for the status, so movement status. So it goes down to this subroutine here, and it checks here to see if that flag's been set. And if it if it hasn't been set, it just returns back to the same place it started from. And again, it keeps coming down here until it actually sees this flag set or the end of movement completed. And then it turns the little blue LED off to indicate that it has done that, and then returns onto the code. So that's as simple as it is. And then what I've got here is I've got a series of movements. I turn it 180 degrees in 2 directions, and here's the second direction. And then I do 3 revolutions back and forth, and then I do 4 90-degree movements really quick, and then we do 4 revolutions really fast, and then basically it should end up at the same place it started. And that's what this code does. And so I'll get it set up so you can see it, and it's ready. Okay, I'll push this button, so it should go through all those motions really quick. I'm going to hold on to it because it actually goes pretty quick. So I'll push the button. So 180, 180, quick 3 turns, then there's the 90s, and the really fast 4 revolutions, all back to the same spot. I'll do it again so you can see it again. Again, you notice the blue LED going on and off, so it's seeing the end of motion. So anyway, that's how you do that. I don't want to bore you with more than that. That's as simple it is to do a lot of motion control with one of these. Again, I want to bring up my spreadsheet here that takes the mystery out of it. So, for example, if I set, you'll notice I set the speed one time at was like 5,000, or in this case here it's, if you look at my little cursor here, this is 5,062. Well, what that means is I've set up my degrees per minute or revolutions per minute. In degrees per minute, it's 16,000 degrees per minute, or 44.4 revolutions per minute, and that equates to the PWM to 5062 for the period on there. And that's what you load in there, and you divide by 2. And then here's the number of degrees of rotation. For example, 180 is 320. If I want to put four revolutions, it's 20 or 25,600, or or a quarter revolution. It doesn't matter. You just put in there which one. It tells you what to put into those values. So you put in that value and that value, and it gives you what you put in. Now it does account for if you have gear reductions. So if you have a gear in there, you put in there. And over here to the left is for linear motion. So it's the same thing. You put in your feed rate, and here's your lead screws, and your gear reductions are all up here. And it tells you what you put in, again, here, for your period, and also for your distance. Here it's in millimeters that you want to move. So that's what you put in those things. So it's really simple, and that's what you put in, and it's nothing more than that. Now, just to help you out, what I'll do is here on these, I can archive these projects out, so you can download them on my website if you're interested in downloading them for yourselves, or you could just pause my video here. You can do these things yourself also. So one other thing I wanted to show you, just because I mentioned it, is there actually is a way to easily do synchronous movements. And so I just want to give you a peek here of how you do a synchronous movement. So basically here I've got an X motor and I've got a Y motor, and again they're tied to one control register. So when I give this register a 1 and a 1 for one for the X and one for the Y, it will run both these motors literally at the same time, based on the speed and the number of steps you do. So that's as easy it is to do synchronous movements. Again, you can do all this with this P-Saco 59 board. So that's really it. It's even easier to do if you buy my control board, and it has easy ways to connect up all the wires, including the fourth wire for the feedback if you want to use that. So anyway, I appreciate you watching the video. Please subscribe and visit my website if you're interested in internet products. I haven't done a video in a while. I've been working on my website, and I didn't realize how hard it is to do e-commerce website. It's actually up and running now. I just have to finish the, so you can look at it now. It is available to see the parts and stuff and the pricing there. And this week I'll actually make it fully active for finance, and I had to get all the legal stuff done to get like the tax number and the bank accounts and all that. So I finally got all that done. There's a waiting period for all that. So unfortunately it's taken a lot longer than so I apologize for that, but anyway, it's up and available. Again, thanks for watching, and I appreciate it. Thank you very much.